Hello there, and welcome to a short video that goes through field size calculation and cell size estimation. So I just quickly want to review calculating total magnification and go through the objective lens values because you'll use those when you perform those calculations. So for starters, when you're calculating total magnification, you always want to multiply objective lens value by the ocular lens value. And the ocular lens value is always going to be the same. So I can go ahead and fill that in here. And I'm using the example right out of the lab manual, so you can kind of follow along, or if you're working through these, you can check your answers. Now on the microscopes that we use in our laboratory, the lowest objective is 4x, followed by 10x, and then 40x, and then finally 100x. To get total magnification and calculate that, you just multiply the ocular lens magnification by the objective lens magnification. So for the first, you'll have 40x as your total magnification. At the next objective, you'll have 100x, and then 400x, and then finally 1000x, and that's your total magnification. So you may need to refer back to this table as you're going in to work through the field diameter. So now let's move on to field diameter. So magnification refers to how many times the specimen is magnified, so how much bigger it looks than it actually is. But in order to relate that to how large the specimen really is, we need to get a sense of how much space there is in that field of view when we're looking. So how big is that circle when you're taking a look there? So to obtain the field diameter, you typically start with a measurement that you take in the very beginning. And I'm going to kind of go through the formula here. I'll come back to it as needed. So a sample that we have here would be where the field diameter was actually measured by a ruler. So this is just a sample. This isn't the actual set of objectives in your microscope. So for example, at a 3x objective, the field diameter, if you measured it with a ruler, is 3 millimeters. Now, why can't you just measure all the other objectives with a ruler? That would be really nice. What happens is as you increase in magnification, the field diameter gets smaller and smaller and smaller, such that you're now in between two lines on the ruler. So you'd really be guessing at what that diameter is, where you can't, say, okay, here's, your three spaces, and that represents 3 millimeters. At the lower magnifications, you can get away with that. But as you increase in magnification, it just becomes too small to actually measure accurately with the ruler. So we use a formula, and I'll go back up here to point that out, where we take the known objective lens value for the field diameter, and then we multiply it by the known field diameter. And that's what we measure with the ruler. And what I would recommend doing is always sticking with that lowest objective lens and that lowest known field diameter, so that the top basically part of this equation always stays the same. And then in turn, then you go and divide that by the objective lens that you are now trying to calculate for. Okay, so let's put that into practice down into this sample table. So if the objective lens, the known objective lens here is 3x, and the known field diameter is 3 millimeters, simply multiply those together, and it's shown here, but I'm going to go ahead and just go through the writing it out there for you a little bit. So you would have 3x times, and don't confuse my times with the 3x, the 3 millimeters, and that's going to give you 9 on the top. And then you would simply divide that by 6x down below. So notice the x's will actually cancel out, and you'll be left with a millimeter answer. So for the first one, you're actually going to get 9. Oh, let me go back to my inking here. You're going to get 9 divided by 6. And remember, that's in millimeters. Our x's canceled out. And that's going to give you 1.5 millimeters, which you would then enter up here. Now for the next one, again, stick with that known objective lens that you have here and that known field diameter. So just keep it at 9 at the top. That way you're not kind of fussing around with trying to figure out which two things to multiply together. You always keep the top two and multiply that. Then you would simply take that same set of values in the top, so the 3 times the 6. I'm going to scroll down here a little bit. So you would have, I'm sorry, the 3 times the 3. And I should correct that. That's millimeters, not meters. But now I'm dividing it by the next objective that I'm solving for. And here we have 60x. So that's now going to give you 0.15 millimeters. Now, in many cases, you're going to have to convert that to micrometers, and we'll get to that in the next table. So I would just fill that out in my table. Now, if this accurately represented your particular microscope, this was just a set of practice problems, you could then just go back to this table and pull these values for whatever magnification you're on. So I'll show you that again in the next table. All right, so let's move forward to the actual table that reflects your microscope. So for the first set, or the lowest objective, it's 4x. And again, we can measure that with a ruler. So if we put a ruler underneath the objective, look through it through the field of view, we actually can measure 5 spaces on the millimeter side. And always make sure that you're looking at the millimeter side and not the inches side, because if you get that first value wrong because you didn't use the right portion of the ruler, it's then going to affect everything down the line. So that would be you have your known objective, and here's your known field diameter. And this does represent what you do have on your microscope. So before we move on to the calculations, I just want to remind you on conversion. So when you're going from millimeters to micrometers, and I'm going to use this as an example, I would simply move 3 spaces over to the right. Zero a little better there, and that would be my micrometers. So I'm going to go ahead and type that in here just so it'll look a little bit prettier. I would get 5,000 micrometers. Okay, so then I want to fill in the remaining objectives, and if I forgot, I can go back up to that table that we did a little bit earlier where we filled all that in. So it was 10x, and then 40x, and then finally 100x. Notice I'm not using total magnification here, I'm using the objective lens magnification. Okay, so going back to the calculation. So again, I'm going to look at the known field size, which is 4x. I'm going to multiply it by my 5 millimeters. Those are my 2 known values. And again, I want to stick with those from here on out so I don't have to remember what to put on the top. And then I'm going to divide it by 10x. And again, the x's are going to cancel out. So I'm going to be left with 20 millimeters over 10, and that's going to give me 2 millimeters for my answer, and that's what I would put up here in the table. Okay, and then when I go to convert that, I'm going to move it 3 spaces to the right, so that will give me 2,000. I'm writing on the screen here, so forgive me for going a little bit out of the table area. 2,000 micrometers. And then I can move on to the next problem. So the next problem is what is the field diameter at 40x? So I'm going to do everything the same, except I'm going to change this bottom value now. So I'm going to do the 4 times the 5 again. But now I'm going to divide it by 40 at the bottom. And that's going to give me 0.5 millimeters, which will now go up here. Again, forgive my scribble here. When I move that 3 spaces to the right, I'm going to have 500 micrometers. And then for the last row, same thing. I'm going to do the 4 times the 5 again. But now I'm dividing it by 100x. I should keep my x's there for my units. Again, the x's will cancel out. And now I'm going to get 0.2 millimeters. So I'll put that up in my table. And when I convert that by moving that decimal 3 spaces to the right, I'm going to get 200 micrometers. Okay, so what do I do with these values? How does this relate to cell size estimation? So these are calculated values. So they stay good for your microscope. The only time you would have to worry about those numbers changing is if you change to a different microscope that had different objectives or different field diameters. So within our lab, all the microscopes have all the same objective lens magnifications and they have all the same field diameter. So if you were working in a different lab and maybe the microscope was different, you might have to go through these calculations again. So what I'm going to do here now is every time I do a cell size estimation, I'm going to go up to the table and I'm going to find the value that I want to use. And so the value that I'm going to want to use is going to be the magnification that I'm on. With the microbiology laboratory, we're always working at 1,000 times total magnification, which is the 100 objective. So I'm always going to be pulling from down here. However, if you were looking at larger specimens, let's say you were looking at eukaryotic cells, then you might actually be working at one of the lower magnifications and you might pull one of those field diameters. But for our purposes, we're going to stay at the 1,000 total magnification, which is 100 times the objective lens, and then we'll use that field diameter. Now, what are you going to use, millimeters or micrometers? Well, what I would probably recommend there is looking at what you're asked for in the problem. If you're asked for micrometers, just make sure you convert to it at some point by the end. Let me make sure that looks clear, like that looks like a micrometer. But sometimes you do start in the millimeters depending on what you're being asked to do. So just look at what units you're being requested and then go and pull one of those two values out. Okay, so that is field size calculation. So now let's move on to cell size estimation. So the connection between these two, in order to know how big a particular cell is, I need to know what that whole space is that I'm looking at. And so sometimes I use the analogy of, let's say you're going to go buy some furniture for a particular room. And let's say, you go into the furniture store, things, you're kind of looking at things, eyeballing, looking at sizes. What you really need to see what would fit in that room is to know how big that room is. To know, is it a 10 by 10 or 10 by 12? And then you can then start to entertain the thought, okay, will this particular item fit? Can I fit 4 chairs? Can I fit these things across the room? So maybe you're looking at a set of beds and will they both fit in the room? So you need that space. And so that space of that room to me is the same thing as a field diameter. It's how big it is all the way across. And then you can start to estimate what will fit inside of it. So let's go down to a hypothetical view here through the microscope. And just to review here on the cell size or cell length calculation, or what I call an estimation, you want to look at that, use that known field diameter. So to get that, I would go up to that table. Okay, so you could either be using 0.2 or the 200. Doesn't matter as long as you're getting the right units at the end. Now, where the true estimation comes into play here is where I'm going to estimate how many cells fit across the field diameter. If the cells are pretty large, a lot of eukaryotic cells are, you can make a pretty good estimation. With bacterial cells, a lot of them are really, really, really tiny. It's an estimation, and we understand that, so we just kind of want to see that you're in a ballpark there. And another tip there is kind of have an idea of what the average bacterial cell size, maybe a bacillus-shaped cell versus a spirillum versus a cocci, so that you can kind of compare those together and see what answers you're getting. So if you're like way, way, way different, you're getting it's 1,000 micrometers instead of 1 to 2 micrometers, something's off there in your calculation. So it may just be a matter of not using the correct units or something. So always kind of have in the back of your mind about where you should be so that when you go through those calculations, just see if you kind of fall into that range there. Okay, so to estimate the length of the cell, you're going to now kind of make a little bit of guesswork as how many cells could be lined up end to end. So this is a kind of sample field of view here. You're never going to have cells lined up neatly end to end, probably very unlikely. So what you do is you pick maybe a couple of cells that look like they're kind of close to end, or maybe just one cell. And then I make a guess as to how many, if I could put a particular cell, how many would fit all the way across there. So let's go back to my writing tool here. So let's say I'm going to use this cell. Another tip here is sometimes when you're looking at cells, you'll see what looks like maybe a range of cells, or maybe it looks like sometimes they're pairs or chains. So find something that's pretty representative of the sample. And I'll talk in a minute about sometimes how you can take advantage of when cells are found in the diplo arrangement, or they're found in a strepto arrangement. So these are bacillus-shaped cells here. So sometimes we call those rod-shaped cells, but the proper term is bacillus-shaped cells. And I'm going to guess here that, and you might guess a little bit different. I'm going to guess that somewhere around, if I were to line these up, 1, 2, and this would be nice. We could do this on the microscope. Of course, we can't. So 3, maybe I got a little smaller, 4, 5. So let's say I'm going to guess 1, 2, 3, 4, 5, 6, 8 cells fit across. Now, if I know what the field diameter is, I can go back up to my table and get this. Now, in this particular figure, we're using 120 micrometers. That's an artificial number. So when we're actually looking at the cells, we would be using the number from up here in our table. So we'd be using the 200. But we're just doing a practice run here. So you could say 120, and I forgot what I said there. 1, 2, 3, 4, 5, 6, 7. Okay, so we could say about 7 cells fit across. And let's say you don't agree with me. Let's say you think 10 cells fit across or 8 cells fit across. Then you plug that number down in the bottom. So you would then just simply go through that division. And so for my sample, and I'm going to pull out my trusty calculator here, say 120 divided by 7. So I get somewhere around 17 cells there would fit across. So I'm going to say or 7 cells fit across, so 17 micrometers per each cell. So that's my cell size. Again, it's an estimation. So you might say 8 cells fit across, or 15 cells. And I think in the example here, they gave you 8 cells. So it's something very similar to that. So again, as long as you're getting in the ballpark. Now, this is a hypothetical example, so this doesn't represent what actual bacterial cells would be like. So we're at least down in the right units that are there, but it's a little bit larger than most bacterial cells. So you can kind of work through the sample problem that's given there. But again, if you know the field diameter, you would simply just take that and then divide that by how many would fit across. This is easy because we did all the hard work for you by guesstimating how many would fit across for you. Typically, you're going to be looking through the microscope, and that's going to be, definitely an estimate because you're looking at that with your eyes. Now, one of the things we do encounter a lot with cell size estimation is you're looking at really, really, really tiny cells with bacterial cells. And so the COTSI in particular are really, really tiny. If you can find areas where they're arranged in a chain, and sometimes even with the cluster arrangements, the Staphylococcus, sometimes you still might find groups of 3 or 4 of those. And let's say 6 of those are in my chain. So what I could do then, if I know the, again, go back to that field size calculation, what that field diameter is. So let's say I say there's 6 in a chain, and let's say 10 of those chains about would fit across that field diameter. So I would just say, okay, there's 10 chains and 6 in each chain. So about 60 cells, and then I can use 60 to divide that in. So sometimes that's a little shortcut. Sometimes you don't have that opportunity. You just have a single cell, and you really just have to eyeball it and say this is how many would fit across. Some microscopes have a pointer, and that also goes about halfway across the microscope. And so you can say, okay, how many would fit along this pointer if I were to estimate, and then just double that since that's only halfway across. So little kind of tricks there. Again, if you have a bacillus shaped and maybe you have diplobacillus, you could say they're in pairs. So let's say, again, you say, okay, there's 2 in each arrangement, and let's say for each short chain there, let's say 50 of those chains would fit across. So then I'd say 100 total, because there's 50 of the chains and 2 in each chain. Just little shortcut things that can help you a little bit and save time. But also just looking at a single cell is okay too, and guessing how many would fit across. Again, it is an estimation, so I think that's a little bit agonizing for science students sometimes because they want a correct answer. It's an estimation, so we're just trying to see that can you get in the ballpark there with the cell size. And that can be really critical for identifying bacteria in addition to staining, is knowing not only shape and arrangement, but also size as well. Okay, I hope this has been helpful for you and helps you with that. Set up some practice problems for yourself where you just estimate how many cells fit across. You can always pull out a microscope in lab, use a stained specimen that you have or pre-prepared slides, and just kind of practice this. So remember, once you've done that the field size calculation, you can always go back to that table. Those numbers stay the same. The number that changes is that cell estimation, how many would fit across. But the top number, which would be your field size, we'd be using 200 on ours, will always stay the same. Okay, I hope that's been helpful, and I thank you very much.